Let's start. Everyone remembers their old school piece of graph paper here. Can you graph that point? Yeah, we all can, right? 1, 2, 3, 4, 1, 2. We can graph that point. Today, how do you graph points on the polar grid? All right. These on this graph paper, it always came in the form of x coordinate and y coordinate. All right, right? When we go on the polar grid today, it's not going to be x, y. It's going to be in this form. An r value, which is how far away from the center I'm going. You guys see all these rings here? All right, that's how far. So if I say this number's 2, I'm going 2 to the second ring here in some direction. What direction? That's the second number will be here, which is the angle. You guys are masters at that now. You'll see an angle in degrees or an angle in radians. If it's in degrees, what am I going by? How many degrees? Still 15. If it's in radians, how many radians am I going by? Pi over 12. So let me just give you a little sneak peek before we actually do some on your notes. Let me take 4 and I'll go 60 degrees. Make it easy. Is that one of them today, by the way? I know. All right. 4, 60 degrees. 60. You know where that is?
Yeah.
I hope so, right? We've been in 2 days of it. So I got 0, 15, 30, 45. Here's 60. So there's 60 degrees. This tells you how far out you're going to go from the center. 1, 2, 3. There's my point. Okay, that's how we're going to graph today. Of course, I wish it was that easy. There's a little hiccup in the middle. Alexa, go.
Are we still doing the arrow to show if it's like...
No, I'll talk about that. Okay, we don't need to do... I don't even need this anymore. I'm just going to have you guys do that till you become a little better at it. Okay, that's the point on the graph right there. There's the point. I want you to graph. All right, so let's try a couple out. First one, I'm going to go radians. Anybody got a problem with pi over 4? What's your problem? It's not out of? It's not out of 12. We only work out of 12. So how do we make it out of 12? Multiply by 3. So really, same point we're going to graph is 3. If you multiply top and bottom by 3, what is it? 3 pi over 12. So the first thing I want you guys to graph is the angle, just like we did yesterday. 3 pi over 12. You got your initial side. And now you just count off, count 3. In which direction? Counterclockwise, yep, up. 1, 2, 3, here it is. Here's the angle. There's 3 pi over 12. Now that I go to the r value, the first number, which is 3, and that's how far you're going to go from the center. 1, 2, 3 circles out. There it is. There's your point. And again, just like I was telling Alexa, you guys will decide. I don't care when you do it. You don't need the angle graph. I just like the angle graph at first because you guys are beginners, so you can see where exactly the point is. But eventually, that's what I need to see. Okay? I just need the point. I don't need the angle anymore. I just want to graph a point. All right, ready? Next one. Any issues with this one? All right, how about 2, 135? Where's this on the grid? So you guys got. I don't know how you guys are finding 135. That's up to you. I have my own method, but however you start counting by 15s. I go start right at 90 and count by 15s, but whatever floats your boat. So 90, 105, 120, 135. And 2 away. First circle, second circle. Okay, anything before I change it up? What's different?
-3.
I got a negative r value. So we have to do something different. I just can't graph that like I showed you. Okay, we have to do something different if there's a negative in front of the R value. Go ahead, graph 3 pi over 2. This is going to help you. Graph 3 pi over 2. So what are you going to multiply first by? Yep, multiply top and bottom by 6. Go ahead. -3. And now your angle is what? 18 pi over 2. All right, go ahead. Graph 12. Sorry. Relax. Somebody jumps down my throat there. Go ahead. Graph 18 pi over 12. Wherever you think that is. I hope you know where it is. Remember, it's 24 all the way around. So if you want to count backwards, if that's easier for you, or just count up to 18, going counterclockwise. All right, here we go. What effect does the negative have on the R value? I am not going to go here or here, too. I'm going to go opposite my angle. I'm going to go opposite. And that is why I had you guys pick up straight edges. Make sure you tell them I said hi in the text. All right. You're going to go opposite. You're going to go opposite the angle. Okay. Opposite. Everybody good? Going to go opposite. So instead of going to here, I'm going to go to the opposite direction. And here's my point. Do you need the straight edges? No. It always helps me because, especially when I start getting like a diagonal line, I know where the opposite side is.
Wait, 2? It's 3.
Oh, 3. Sorry. Yep. Got rattled there, of course.
I didn't say 2.
So if it's negative, I go directly opposite the angle. All right, next one, negative pi over 4 with a -1. So I know I'm going opposite, but I still have to graph -4. Negative pi over 4. What are you multiplying top and bottom by? 3. Yep. So I have -3 pi over 12. Which direction you going? Make sure you count down, right? Count down clockwise 3. I'm still graphing the angle, whatever it is. I'm still graphing it. Yes.
So is it possible to multiply the negative pi over 4 by -3? Or is it like not possible?
I guess you could. Yeah.
Should it work or can you just like
Just put the point. Put the point. It's -1, so we got to go opposite. If you want to grab your straight edge and make sure you go opposite. All right, because sometimes it's hard. The lines run into each other. And there you go. Everyone all right what I mean by directly opposite your angle?
Yes.
Only when it's negative. All right, on your own now. Graph those 2 points on the same grid for me. On the same grid, graph those 2 points. And hopefully all of us have the same, not issue, but conclusion. Anybody running in the same? Not, it's not a problem, but in conclusion here. Anybody have two different points on their graph? Good. You shouldn't. They all land at those 2 points are the exact same points on the graph. So here's how we're going to end class with here, these last two. I'm going to give you a point on there, and I want you to give me a couple different other points that land in the same spot, just like those two did. All right. Let me give you a little hint, a little help with that on how can you do this. All right. How can I find a new point that's going to land in the same spot? Two different ways. So you start out with your normal point, R and your angle, right? R and your angle. Let's say I keep the sign on R the same. I don't switch it. R stays the same. What would I need to add to my angle to get another point that's exactly the same if R stays the same? I don't go in reverse. I'm staying right here. If R stays the same and I come all the way back around, what did I do with my angle? I added 360. Is that the only way I could go right here? I could also go this way. So I could add or subtract 360 to get to the same point. So I'm going to take my angle and add and subtract 360 from it to get another point that ends up in the same location. What if you wanted to change the R value? So R and your angle, you wanted to change the sign on the R value. You can't go 360 again, right? Anybody remember from your geometry days? Going from here to here? How many degrees that is? A straight line? 180. 180, there you go. So if you want to change your R value, you can, but you're going to have to add and subtract a $1.80 instead. One last thing. Are we always in degrees? We could be in radians, right? So that doesn't make any sense to add and subtract 360 to it. I would need to add and subtract. Good, good. Ooh, it's been a while. 180? Pi, yes. Instead.
You can pick if you want to subtract or add. Is that?
I'd like you to do both at the beginning because you're going to see, Molly, now go to number 2. All right, I got 7 and 140. There could be more than one answer here. This is not just multiple choice, pick one and you're done. Which or how many of these 4 would also land on 7 and 140? All right. Desperation, there's always a desperation method in math. Just graph them all, right? Just graph them and see which ones falls on there. All right, I want to do it algebraically like I just showed you here. So 7, 140. Let's find 2 more points that would land in the same spot. So let's say I kept the R value. I want the R value to remain 7. What are you going to do to 140? Add and subtract 360. Go ahead, and that'll give you 2 more points that would be in the same location. So when you added 360, what'd you get? 500. And when you subtracted, you probably got negative, 220. So at least one of my answers is here, right? 7, negative 220. So all 3 points would end up in the same location. That's not the only way to do it, though. There might be more up here that land in the same location. You could also go in the opposite direction, right? And change that 7 to negative 7. If you do that, though, when you go on the opposite side, now I add and subtract 180. Go ahead. So this method here will find you 4 different points that end up in the same location. So add 180, 220. No. 320. And when you subtract 180, negative 40. Looks like I got two more answers up here, huh? That land in the same spot. Negative 7, 320. Negative 7, negative 40. All three land in the same spot. How would I do this on a quiz? I would do it like this question, or I would say, give me two new points, one with the same R value and one with an opposite R value. That's how I would probably ask it on the quiz. All right. Questions there before we go radians and we're done. All right, let's go. So how many of these up here are the same location as 2, negative 3 pi over 4? I checked all your assignments yesterday. We had a handful of people that don't like to deal with radians. They just want to stay in degrees. I'm okay with that. But remember, you have to convert it back at the end to see which one it's going to be. All right, so if you want to change negative 3 pi over 4 into degrees, add, subtract 360 and 180, feel free. Might take you a little longer, but make sure you convert back at the end. I'm going to do the same thing I've been showing you guys, and that is keep the R value. Now we're going to do what? Negative 3 pi over 4 plus, can't do 360, 2 pi. And then we're going to do minus 2 pi. And I get it. Some of you guys are uncomfortable doing that. Change it to degrees. Just make sure you convert it back at the end. Common denominator of what? 4. Yeah, you guys can do this. All right, you just got to get over that confidence hump. You can do this. Negative 3 pi stays the same, and you multiply the 2 pi by 4. Give you an opportunity to do it. Yes, sir.
For this one, you wouldn't do the negative 3 pi over 4 and like multiply to get it with its denominator as 12.
If you want to graph it, yeah. That's fine if you wanted to graph it. My worry is if you look up here and your choice is nothing's out of 12.
Yeah.
So you would have to reduce. Yeah, okay, here you go, sir. Yes, you can. You're just be prepared at the end to reduce your answers. Okay? Because none of those are out of 12. So, all right, let's see. What do we end up with? That's negative 8, negative 11 pi over 4 here. And then over here, no, you don't. Yeah, you do. Negative 11 pi over 4. And then here, multiply that by 4. No, relax, Molly. That's 8, so that should be 5 pi over 4, right? Better? And then this one should be the negative 11 pi over 4. So I got one answer down, right? 2 comma 5 pi over 4. I'll review the adding. Anybody want to go over with the unlike denominators there? Yes, Nora, go ahead. All right, this is over 1, Nora, right? So what's your common denominator? 4, right? Well, that's already a 4, so no need to multiply by anything. Negative 3 pi. What do you have to multiply this by? 4, yep, you got it. So that'll be plus 8 pi. And that's how we get 5 pi. All right? All right, and finally, you could also change the R value. So if I change this bad boy to negative 2, what are you going to add and subtract now? 180, aka pi if it's in radians. Plus pi minus pi. What's still your common denominator? 4, yeah, but it's not going to be 8 pi. It's going to be 4 pi when you multiply. pi over 4. Negative 7 pi over 4. And what do I got? Only one of them, right? 4. Everything else is, nope, that don't match.
Do we have to plot the points or no?
You can. That's the other way without doing all this algebra. You can plot them and see what does match up. But I might ask on the quiz, give me 2 points that are the same, one with a positive R value and one with a negative. So I don't know if graphing is really the best in that case. All right, Molly.
Can you go over? I got 7 pi and then negative 4 pi, like my sign.
Okay, so this one here, this would have been negative 3 pi plus 4 pi. Right here. That's what I would get here because you multiply this by 4.
I thought it was, you don't do 3 pi over 4 minus.
Well, that's down here.
Yeah, that's so dumb.
So now it's going to be negative 3 pi minus 4 pi over 4.
Oh, I forgot to bring the negative sign down.
You okay? Everyone else? We good? Okay.
So it's negative 7 and then 1.
Positive 1 pi over 4. Yep.
It's more like overall.
Bring the negative.
And not high.
That was the quickest class.